Right, in this experiment we're going to do the preliminary investigation where we need to identify the exact frequencies or exact wavelengths of light that we're going to be using with the photocell. If you remember from the photocell experiment, the frequency of light is our independent variable and the stopping potential is our dependent variable. And we're going to plot a graph of stopping potential against frequency, and we're going to use the gradient to find Planck constant. Okay, now it's obviously very important that we have a pretty accurate value for each value of frequency to plot on our graph. So this is how we're going to do it. We're going to use this thing here. This is the Pasco spectrometer. Here's the light sensor here connected with a fibre optic cable. I've got a regular torch. Well, it's a LED torch, and this is the important bit. We've got a range of 8 coloured filters. Now it does say we've got all different colours going from red right through to violet in the visible range of the visible spectrum. So it does say that give the wavelength, or gives a ballpark figure for the wavelength on each. Well, this is the first one, red. It says 620 plus nanometers. Next one, orange. It gives 575 to 610 nanometers. However, it would be really useful to know where the peak is, okay? Because that's going to be much better to plot on the graph. That value of peak intensity, the value of wavelength that gives the peak intensity from each filter, and that's where this fella comes in. That's where the Pasco spectrometer comes in, and we've got the software which is going to help us identify it. But this is the Pasco spectrometry software. And we're just literally going to identify where the peak intensity is. So if we get started with, so that's the spectrum of light from just the torch on its own. Now, admittedly, yeah, we've got 2 peaks. We've got quite a narrow peak in the blue, but we've got a much broader sort of peak that runs through the green, yellow and orange part of the visible spectrum. Okay, there's a bit of a dip in the middle at blue, but if we turn it off, you can see that we're definitely getting some intensity from all wavelengths in the visible spectrum. Okay, so first up is red. So is that one there? Okay, so it says 620 plus. Where's the exact peak? So just put it in front of the torch. Now, as you can see, the intensity is quite down. So if we knock the sensitivity of the app up, now this tool here helps us identify the peak. So it's about 638, isn't it? 638 nanometers. Let's try 644. No, that's well over, isn't it? 650. Happy with that? Right, first wavelength, 651 nanometers. So that's the red filter. 651 nanometers. Next up, orange. Okay, the orange filter. So the peak is round about 580. Bit more. That'll do. Right, 586 nanometers is our peak for orange. Next up, it's called orange. So this is orange 2. The first one was orange 1. That's orange 2. Now orange 2 is into. Already we're getting a much bigger intensity, but the peak is in a slightly different place, isn't it? So let's see. That's round about 578, isn't it? Bit less. Okay, there you go. So that's orange 2, 576 nanometers. Next up is yellow-green. Says 530 to 570 on the filter, but we're seeing there's the peak there. So again, this is one where we have to put the sensitivity up, but we can see a very definite peak around about 540 nanometers. There you go, spot on. So there's your peak there, maybe a bit more, 542, 541, 541 nanometers. There's your peak for the yellow-green filter. Next up, this one's just called green. Okay. Now again, we've got, this is one which gives us a more impressive intensity. So that's around about 530 nanometers by the looks of it. A bit less. .525 nanometers. So that's the green. 525 nanometers. Next up, blue-green. So around about 500, that, isn't it? A bit more, maybe. .504 nanometers. 503 nanometers. There you go. So there's your peak for blue-green. 503 nanometers. Next up, deep blue. It says 430 to 480 nanometers. Let's find out where the peak is. So getting a nice intensity there. So that's looking about 450, maybe less, isn't it? 450. So let's try 450 to get. That's pretty close. 451 nanometers. Okay, so that is deep blue, 451 nanometers. And finally, last but not least, we have violet. Okay, it says 380 to 450 on the slide, but let's find out where that peak is. So just a little bit less, isn't it? That looks pretty good. 444. Okay, so the violet filter, the last 8 of 8 is 444 nanometers. Okay, right. So obviously we've still got, you know, a range of frequencies, a range of wavelengths for each filter, but there's a very definite peak, and it's quite a sharp peak in all 8. But there's definitely going to be a plus or minus, isn't there? There's definitely going to be a plus or minus. There's going to be an uncertainty in that wavelength, which would perhaps help us with plotting error bars in our final graph. Okay, so that might be something to think about. Right, thank you very much. There's your little starter practical, identifying the wavelengths. Right, thank you very much. See you in the next video.